Hi, this video class goes on continuing. Now to take the continuation of Laplace transform of BSc 5th semester mathematics. In this class, to go further, examples on inverse Laplace transform. In this class, to take the examples on inverse Laplace transform. Already we did the examples on a Laplace transform. Now with the help of that Laplace transform to work out the some examples on inverse Laplace transform. For this it is very necessary and important to recall the things of Laplace to inverse Laplace. Look at this one. What does the L of t raised to n? We know that L of t raised to n is a n factorial divided by s raised to n plus 1. So in terms of inverse, you can write this L come to the register side becomes a L inverse. L inverse of n factorial divided by s raised to n plus 1 is a t raised to n. Why it is so far? Because L of t raised to n is a n factorial divided by s raised to n plus 1. So the n factorial, it is within the L inverse. That constant, n factorial is a constant, you may transfer it into the right hand side. So now the result may be alternately written as a L inverse of 1 divided by s raised to n plus 1 equal to t raised to n by n factorial also. Yes, if n equal to 0, then what happens? We get the one more result. If n equal to 0, the L inverse of it comes 1 by s raised to 0 plus 1 as a s raised to 1 are written as only s. L inverse of 1 by s. It is n is 0, t raised to 0 by 0 factorial, t raised to 0 is 1, 0 factorial is 1, therefore the total result is 1. Hence we can say L inverse of 1 by s is a 1. L inverse of 1 by s is a 1. As n equal to 0 can be taken in the main result, we get the result L inverse of 1 by s is 1. We know already what is L of 1. L of 1 is a 1 by s. L of 1 is a 1 by s. Therefore, L inverse of 1 by s 1 also. Suppose if n equal to 1 in this result, what happens? If n equal to 1, that L inverse of 1 raised to s, L inverse of 1 by s raised to 1 plus 1. That is L inverse of 1 by s raised to 1 plus 1 is a 2. Then immediately the t raised to 1 by 1 factorial, that is nothing but the t. So L inverse of 1 divided by s square is a t. Similarly, what happens if n can be taken as a 2 in the main result? The main result is this one. In this, n can be taken as a 2 means 1 by s raised to 3 it is. Now immediately it is t square by 2 factorial. 2 factorial is nothing but a 2 and so on. That means and so on means we can put n equal to the numbers. We get the 1 by 1 results. Okay, you have to be practice what happens n equal to 0, n equal to 1, n equal to 2, n equal to 3 and so on and so forth. So this is the very important result appears in solving the inverse Laplace transforms. Next page, I can go as examples on inverse Laplace transform. Examples on inverse Laplace transform. Consider the first example. Find the inverse Laplace transform of 2s square minus 5 into s plus 8 divided by s cube. So I want to find out the inverse Laplace transform of the given expression. So I operated the L inverse to the given expression. So L inverse of 2s square minus 5s plus 8 divided by s cube. This s cube is in the denominator. It is very much linked with all the terms of a numerator. That means you have to split this s cube for both all the numerator terms. That s cube is divided to the first term, s cube is divided to the second term, s cube is divided to the third term. What happens? It is L inverse of 2s square by s cube minus 5s by s cube plus 8 by s cube. Cancel the terms of s square and s square. We get a 2 by s in the first term. S and s cancel. You left a 5 by s square, 8 by s cube. So it is L inverse of 2 by s minus 5 by s square plus 8 by s cube. Taken L inverse to all the terms because there is the plus and minus in between the terms. The linear property is applied, directly N inverse is applied for all the terms. L inverse of 2 by s, 2 is constant, I put outside the inverse laps. So it is 2 into L inverse of 1 by s minus 5 into L inverse of 1 by s square plus 8 into L inverse of 1 by s cube. So it is the very familiar thing, 2 into, what is L inverse of 1 by s? Just only we discussed that it is a 1. What is L inverse of 1 by s square? T. then L inverse of 1 by s cube is a t square by 2 factorial. Simplification leads the answer 2 minus 5t plus 4t square. So the result, the answer for the L inverse of 2s square minus 5s plus 8 divided by s cube is 2 minus 5t plus 4t square. So consider the next example. Before that, I will highlight this first shifting property. As you know that only L of t raised to n, L of t raised to n, n factorial divided by s raised to n plus 1. But the first shifting property says that e raised to at is attached to the t raised to n, that L of e raised to at into t raised to n becomes a, that s changes to s minus a. Remaining things is same. L of e raised to at into t raised to n is n factorial divided by s minus a raised to n plus 1. From this, the L inverse of 1 by s minus a raised to n plus 1 is a e raised to at into t raised to n divided by n factorial. Keep in mind this one and work out the some examples. The question is, find the L inverse of 1 by s minus 4 raised to 3. L inverse of 1 by s minus 4 raised to 3. Comparing this with the L inverse of s minus a raised to n plus 1. The a place is 4, n plus 1 is 3. Make it only the a is a 4, n plus 1 is 3 means n is a 2. It is e raised to at by t raised to n by n factorial becomes a has been put 4, n has been put 2, then it is e raised to 4t divided into t square divided by 2 factorial. So we have the answer L inverse of 1 by s minus 4 raised to 3 is a e raised to 4t into t square by 2 factorial. Similarly, look at the second result. Find L inverse of 1 by s minus 2 raised to 5. Comparing with the standard, L inverse of 1 by s minus a raised to n plus 1, where a is 2, n plus 1 is 5 means n is 4. Therefore, L inverse of 1 by s minus 2 raised to 5 is a e raised to at means 2t into t raised to n means t raised to 4 divided by 4 factorial. Often we can write 4 factorial has to be 24. Therefore, L inverse of 1 by s minus 2 raised to 5 is e raised to 2t into t raised to 4 divided by 24. Look at the next result. Now the things becomes so and so easy after solving the 1 by 1 example. What does the L inverse of 1 by s minus 3 raised to 5? Where look at this one, comparing with the s minus a raised to n plus 1, a is 3, n plus 1 is 5. So we have e raised to 3t into t raised to 4 divided by 4 factorial. Look at this one, again it becomes so easier than the previous. What is that? L inverse of s minus 1 raised to 3, where a is 1, n plus 1 is 3 means n equal to 2. Therefore, it is e raised to t divided into t square divided by 2 factorial. All these results are solved by means of a first shifting property, that is L inverse of 1 by s minus a raised to n plus 1 equal to e raised to at into t raised to n by n factorial. Okay, instead of s minus a, I will take an as a s plus a now. What happens? Find L inverse of, in the next example, find L inverse of 1 by s plus 2 raised to 3, where it is a is minus 2, n is 2, because n plus 1 is 3 means n is 2. Therefore, it is e raised to minus 2t into t square by 2 factorial. Similarly, the L inverse of, in the another example, find L inverse of 1 by s plus 1 raised to 3, where a is minus 1, n plus 1 is 3 is n equal to again 2. Therefore, it is e raised to minus 1t is nothing but e raised to minus t into t raised to 2 divided by 2 factorial. Look at this one. This example is different from the previous examples. Find L inverse of s divided by s minus 3 raised to 5. S divided by s minus 3 raised to 5. In the previous example, there is no numerator term. Numerator is a constant, 1, maybe 2, 3 like that. But here it is a s. So, s divided by s minus 3 raised to 5, it does not have a direct answer. Therefore, I use the mathematical trick here. If the bracket is s minus 3, I will make it minus 3 and plus 3 in the numerator. Adding and subtracting the 3 in the numerator step. So it is L inverse s minus 3 plus 3. Make it the one term in the numerator as a 2 term by means of writing a plus 3 and a minus 3. what happens? The first term is s minus 3, second term is 3. Splitting this denominator for both the numerator terms, what happens? This one s minus 3 by s minus 3 raised to 5, separately L inverse I taken. Then 3 divided by s minus 3 raised to 5, separately L inverse has been taken because of linear property. The s minus 3 cancels. In the first bracket we have L inverse of s minus 3 raised to 4. Next it is 3 is a constant. Now I left the L inverse of s minus 3 raised to 5. Therefore we have the L inverse of s minus a raised to n type. It is e raised to 3t, t raised to 3 divided by 3 factorial. 3 as it is, here it is also e raised to 3t, t raised to 4 divided by 4 factorial. Making e raised to 3t common from these two, we have a t cube divided by 3 factorial, 3 into t raised to 4 by 4 factorial. So this is the little different than the previous examples. To go for the another one, find L inverse of 1 by s into, find L inverse of 1 by s into s plus 1 into s plus 2. We do not have a direct answer for this one. 1 divided by s into s plus 1 into s plus 2, the product of the three terms in the denominator. So our inverse Laplace transformation does not give the direct answer for such examples. And that time you have to be split that 1 divided by s into s plus 1 into s plus 2 by means of a partial fraction. To consider only the inverse result of bracket, that is 1 by s into s plus 1 into s plus 2, using the partial fraction. In the denominator there are the three linear terms. Three linear terms are s, s plus 1, s plus 2. By means of partial fraction, how to split this one? A by s plus b by s plus 1, c by s plus 2. So our idea is to find out the values of a, b, c. There are three terms a, b, c constant. To find out the values of a, b, c, in the LHS it is a 1 by s into s plus 1 into s plus 2. There is the RHS, taken the LCM. LCM also becomes a, in the RHS, s into s plus 1 into s plus 2. Whenever the LCM has been taken, both the denominator of LHS and RHS are same. Cancel them. What you left? 1 is equal to a into bracket s plus 1 into s plus 2 plus b into bracket s into s plus 2 plus c into bracket s into s plus 1. So I want to find out the values of a, b, c. For that, there are the three linear product. I says s, s plus 1, s plus 2. Suppose we put s equal to 0. S equal to 0, the LHS does not affect, it keep as a 1. Whenever s equal to 0, the second and third terms become 0 because 0 into s plus 2, 0 into s plus 1. These two terms becomes 0. Whenever s is 0, in the first bracket it is 0 plus 1, 0 plus 2, 2 into 1 is a 2, 2a we left. Therefore 1 equal to 2a or a equal to 1 by 2. Next, put s equal to minus 1 here. S equal to, whenever we put the s equal to minus 1, the first term becomes 0, last term becomes 0. S equal to minus 1 affected in the second term. It is 2 minus 1, 1, 1 into minus 1, minus b. Minus b equal to 1, therefore b equal to minus 1. Similarly, put s equal to minus 2, this bracket becomes 0, this bracket becomes 0, that means first and second terms becomes 0. Whenever s equal to minus 2 here, it is minus 2 into bracket minus 2 plus 1. Minus 2 plus 1 is a minus 1. Minus 1 into minus 2 is a 2c. That means RHS we left a 2c. There is the LHS 1. Therefore c equal to 1 by 2. Put all these values in the a, b, c. Here it is the a, b, c. Put all these values. Therefore 1 by s into s plus 1 into s plus 2 is equal to 1 by 2 divided by s plus minus 1 by s plus 1 plus 1 by 2 divided by s plus 2. Operate L inverse for both the LHS and RHS. Therefore, L inverse of 1 upon s into s plus 1 into s plus 2 equal to, taken 1 by 2 common, constant L inverse of 1 by s minus L inverse of 1 by s plus 1 plus 1 by 2 into L inverse of 1 by s plus 2. So we have the direct answer 1 by 2. L inverse of 1 by s is a 1. It is a e raised to minus t, and this one is a e raised to minus 2t. And it may taken 1 by 2 common from all these three terms. We left a 1 minus 2 into e raised to minus t plus 3 plus e raised to minus 2t. So this work is all happened by means of partial fraction and the inverse Laplace transform. Inverse Laplace transform is only one step here. After splitting the terms by means of a partial fraction, it has the only one step. We get the direct result. Before that, what we did, it is already learnt step in the previous years PUC first year level. We did this partial fraction work. You have to recall it at a suitable time and use this one and get the answer for the example. Next, go for the L inverse of s plus 2 divided by s square plus 4s plus 29. L inverse of s plus 2 divided by s square plus 4s plus 29. This ninth example is so different from the previous what you did. So students, keep concentrate on the already, so what you solved the examples. You have to practice it again and again and be perfect. In the next class, I will continue my class by means of this example. Thank you.